is known as a Smith chart was devised by, because why the Smith is coming, because of its inventor who actually formed this tool. This is the scientist P.H. Smith. Okay, so he actually proposed this one, and this is a graphical tool which is a chart which is a plot of a normalized resistance and the reactance. Okay, so very quickly I will explain you how this chart is formed. And so it's you can say application is that it is used for doing the calculation for the input impedance, reflection coefficient, and there are other more application for this, for calculating the impedance matching. There are various techniques for impedance matching: single stub, double stub, quarter wave transformer. So all those kind of schemes are there. Okay, so let us see how far we can go into this application. But today I am just introducing this and how this is formed. Okay, so let us see this one. So the Smith chart is drawn on the complex plane. So first thing that is you should aware of that this is the reflection coefficient, and as I told you that this is made up of the its magnitude and its angle. So you can also represent it as in the real term and in the imaginary part. Okay, this is what is shown here. So this is the real part. As you have a normal graph, okay, you have x-axis and the y-axis. So along x direction you have gamma r, and this is gamma I. Only the thing is that this is plotted for in a circle where this mod is less than equal to 1. Now, first thing that we used to do is that we used to calculate the normalized impedance. Okay, normalized impedance, which is a kind of a, you can say, made up of a normalized resistance and the normalized reactance. Why this normalized? Why not a simple value? The reason is that because you have seen that the characteristic impedance usually is of 50 ohm, but if you are changing the characteristic impedance, the transmission line whose characteristic impedance is let us say 60 ohm, 75 ohm, or maybe 100 ohm, then if you are not normalizing that, you will need a separate Smith chart for all these kind of a transmission line, which is not possible. Okay, so that is why we used to have the normalized impedance, and the same Smith chart can be used for any purpose, for any type of this characteristic impedance. Now see here, this gamma, which is a real part shown here, imaginary part shown here, because it is 90 degree, J is 90 degrees, so that is why it is going here. A point is, a reference point is shown here just for an example, that if you have this point, so the length of this will going to tell you the magnitude of this one, and the angle which this line will make the real axis is called as theta of gamma. See, later on we will see that this is so simple that you just trace a point and the next step is the answer with you. And in the analytical calculation, you have to substitute and then do the calculation, then you will have the values. But here that is not, it is very simple. Okay, so if you have this reference point and if you see that you are coming closer to this and you are coming to the center, so when you are saying that the gamma length of this line is specifying the magnitude of this gamma, so it is obvious that at this point, at the center, the value of gamma is 0. If gamma is 0, you know, S is related to gamma, so this S value is 1. Let us see how the Smith chart is created. Let us see that part. Now, assuming that the transmission line is lossless and this is the load ZL. So the first thing is that what is the normalized impedance? Normalized impedance or the normalized load impedance is the impedance where you divide ZL by Z0. So you can represent it by small ZL. So when I write on the slide or on the blackboard, or when you write on your notebook, you cannot distinguish between the capital Z and the small z. So it is recommended that for normalized one, you write ZL by putting a bar over this, which indicate that you are actually representing a normalized load impedance. In typing, you can differentiate a small z and a capital Z, but while writing, we need to follow this convention. Okay, please note. So here, when you have normalized this, okay, because what was gamma? Gamma was ZL minus Z0 upon ZL plus Z0. and you have divided this by ZL. So this first term ZL by Z naught will become ZL, okay, and this will become -1 upon this one. So this is simple. After that, this can also be written in a different form. ZL is equal to, in this form, 1 plus gamma e to the power j theta by this one. And you know that gamma is made up of real and imaginary part. ZL is, when capital ZL is RL plus JXL. So the small ZL, which is ZL by Z naught, this will also be divided by Z naught. So when you divide it by Z naught, this will become small RL plus small XL. This is what is written here. And so this, when you substitute this value here and this gamma in the complex impedance form, you can write it in this way. And you can see that on the left hand side we have real part and imaginary part. We also want the right hand side to come as a real part and the imaginary part separate, so that we can write what is R and what is Z. And we have done that. So we have separated out the real and imaginary part in this step. So usual mathematical technique where you multiply numerator and denominator both by with the opposite sign of the denominator. So that has been carried out here, and you can see that we have the value of RL with us and the value of XL, the real part and the imaginary part. And by doing a little bit of the mathematical steps, you can represent this first term in this form, and the second one is this. In subsequent slide, I will tell you that what happened here, how this RL is converted in this form, and how this XL is coming in this. But after looking into this final form, it is clear that these are the equations of circle. These are the equations of circle, where the first circle, the first equation is known as the equation for R circle, and the second equation is known as the equation of X circle. Okay, R circles and the X circle, where the center of the R circle is R upon 1 plus RL and 0, and the radius is 1 upon 1 plus RL. For X circle, the center is 1 and 1 by XL, where the radius is 1 by XL.